Hey guys, welcome back to chapter 14. In the last video, we looked at strong and weak acids. We are going to take the same route through this one, but we're going to talk about strong and weak bases. So strong bases, again, we need to identify strong, and if they are not strong, then they will be weak. So strong bases are going to be all of the group 1 metals, some of the group 2 metals attached to hydroxide. So the left side here, we've got all of our group 1 metals, so sodium with hydroxide, lithium, and potassium. So if it's a group 1 metal with hydroxide, bam, automatically strong. Group 2 metals, so calcium, strontium, and beryllium are all going to be strong bases when they are attached to hydroxide. A couple things here. One, bases are a little bit wonky. When we start dealing with bases, we kind of treat acids as the standard, and then bases always tend to have some sort of like exception to the rule or an extra step. So when we start dealing with bases, just go ahead and put that in your brain, ooh, it's a base. I might want to be careful here. There might be something that I'll miss. So bases always tend to cause us to do something extra. So the first indication of this is going to be in our group 2 metals. So when our group 2 metals form a compound with hydroxide, there's going to be 2 of those hydroxides that are needed to fulfill this ionic compound. When they completely dissociate, we're going to have 1 atom of calcium, but notice that there's 2 molecules of the hydroxide on the other side. So that's going to be kind of your first thing you want to be mindful of when we start using this hydroxide to calculate things later. Just keep an eye on that. We know that we have 2 of those hydroxides. With strong bases, good rule of thumb, these are going to be strong. Outside of these 6, I'm going to help you with it. Bases aren't as clear-cut as the acids. So if it's a base, I will help you with the weak base, blah, blah, blah. Or I'll say this is a strong base, and here it is. So probably should know these. But outside of these, I will try to help you with acids, or I will try to help you with bases. So for strong bases, we see the same thing that we saw for strong acids. So we see that one-sided arrow, complete dissociation. When we talk about weak bases, they are going to partially dissociate by equilibrium to form that hydroxide ion. Bases aren't as easy to identify, though. So again, I'm going to have to help you out with these. So let's take a look at an example of a weak base. So here's an example of a weak base. Our poster child is ammonia. So I told you that ammonia is a base. Bases are proton acceptors. So when ammonia accepts his proton, he's going to be NH4. So we see that extra hydrogen, and then the plus charge comes with it. For water, he's going to act as our acid, so proton donor. So he's got 2 hydrogens, now he's only got 1. And this formation of hydroxide is a really good indication that this is a base reaction. Okay. So in this weak base reaction, some hydroxide was created, but not very much. Just like we did for our weak acids, we can write a K equation for this. So we're going to write K equals, but again, we're going to put this subscript B to indicate that this is a base, so the Kb value. It's going to be products over reactants, so our products are NH4 and hydroxide. And again, our reactants, water's not included because that's a liquid, but we would put our NH3 on the bottom. So that's going to be the Kb equation for this. Here's just a generic formula for bases. often bases tend to have really, really big chemical formulas. So sometimes students find it helpful just to use the B for base. It's kind of a generic term. We react it with water. We see that base is a proton acceptor, so that's where this hydrogen came from. And of course, this is our proton donor. We get our hydroxide. We can have the same conversation about Kb values. So if Kb values are significantly larger than 1, that would indicate to us that it is a strong base. So most of it dissociates to the product side. And if the Kb value is significantly less than 1, that would also indicate to us that it is a weak base, that there is some dissociation, not a lot. So that would indicate that it's a weak base, partial dissociation. That's pretty much it for introducing you to strong acids and strong bases. From here, we're going to start to look at some examples, some problems of these Ka, Kb values. And then taking that to the next step to something called pH. I hope you guys found this helpful.